All right, today we're going to learn how to add and subtract factors when they're in fraction form. Also, remember, smile. Okay, cool. So the equation that we're going to work on first is going to be this one. 2x minus 1 over 3. This one's going to be over 4. This one's going to be over 2. Now, we can't just add them. We can't add the 2x minus 1 and subtract these yet, or add these parts because they're all over a different denominator. So the first step is this. We want to make them all over the same number because then they're all the same part. And then we can make them one big fraction and then connect this entire bar. Once the bottom is the same, then these guys can cross each other. Imagine this being kind of like when North America and Asia were separated by water, but then there's a bunch of ice connecting them, and the ice that's going to connect them is making the bottom the same. All right, anyway, I'm not a geography teacher, I'm a math teacher. Cool, so let's get into it. Okay, so in order to figure out how to make the bottoms all the same, we need to figure out what's their lowest common multiple. So the lowest common multiple of 3, 4, and 2, I put them all down here. I just put out like here, 2 times 2, 4, 6, 8, 10. And then 3, 6, 9, 12. And for 4, 4, 8, 12. So what I found was that 12 was the lowest common multiple for all of these. You don't want to do anything larger because then you're just going to do unnecessary multiplication, and unless you want to make math harder, I don't think anyone does that, so let's just not talk to those people. You want it to be the smallest one. So 12 is going to be the lowest common multiple between all these. So then you're going to want to make this over 12, that over 12, and that over 12. So that's what we're doing down here. To make this over 12, we're going to multiply both the top and the bottom by 4. If we were to just multiply the bottom by 4, then our entire answer would be 4 times smaller. And we don't want to necessarily change the answer. We just wanted the bottom to be the same. So if you multiply the top and the bottom by 4, 4 over 4 is the equivalent of 1. So we're really not changing it by anything, right? Like if you multiply 5 by 1, it's still 5. So that's what we're doing here. We're going to multiply this by 4 over 4. This one, since it's over 4, in order to get it to 12, we need to multiply by 3. So we're going to do 3 over 3. And for this last one, since it's over 2, we need to multiply it by 6 to get to 12. So 6 over 6. And when we do this times 4, 2x minus 1 is going to become 8x minus 4. And then we get over 12. And then this part, what used to be over 4, when we multiply it by 3, it's going to become 12x minus 3 over 12. And then this last part, x minus 3, when we multiply all by 6, it's going to be 6x minus 18 over 12. And then the last step is to combine them all. So let's do that. Okay, so I want to make it one big fraction. So we're going to do 8x minus 4 minus 12x minus 3 plus 6x minus 18, all over 12. Okay, now I made one mistake. You have to worry about this. Since this is minus, that's going to be minus 12x. But it also means minus 3. So that minus 3 isn't correct. We need to do minus 3. So we're going to make that negative plus. So just keep in mind whenever you have subtracting and you have stuff like this, you need to add that negative to both sides. So it's going to be making this 12 negative and it's making that negative. So a negative number is positive. If only you can make negative people negative by being more negative to them. Anyway, let's go back to math. So now that we have everything all over 12, let's just combine everything. This is basically like really simple addition. So If you want, you can skip ahead a couple of seconds and this will all be done. All right, 8x minus that is negative 4x plus 6. That gives me 2x. Minus 4, that is negative 1. That is negative 19. Okay. Ta-da! That's our answer. So the general idea is in order to subtract and add these things, we need to make sure that the bottom is the same. Because if they're not the same, then we can't combine them. We can't make that bridge between them. So we need to figure out what's the lowest common factor between these three, figure that out, and then multiply each of them so that they're over 12, or over the same lowest common factor, or lowest common multiple. All right, let's do another problem. Ooh, this is tough. I take that back. This just looks tough. Technically, this is basically the same thing. We just have different parts. So we have number parts, we have x parts, and we have y parts. But the nice thing is they're all kind of separate, so it's not too bad. All right, so in order to add them, we need to have what be the same? We need to have the bottom be the same. So that means this guy and this guy need to be the same. So we need to figure out what is the lowest common multiple between this. Now, how do you do that? Okay, so what we do is this. Let's take these two together, 2xy cubed and 6x squared y, and let's ask ourselves this. What do they both share in common? Let's first look at the numbers. I'll do this, like numbers, x, y. Okay, so 2 and 6. What can you take out from both of them? You can take out 2, right? So take out 2. For x, what can you take out? How many x's can you take out? This one has less x, right? This only has just 1x. This one has 2x. So that means we can take out x from both of them. So we'll just put x. And then for y, this one has more. So let's not look over there. Let's look over here. This guy only has 1 y. So that means we can take out y. So we can take out 2xy from both of these. So what do we get when we divide this guy by 2xy? 2xy cubed divided by 2xy gives us y squared. And then 6x squared y divided by 2xy, that gives us 3x. Okay. The reason I did that was because now I need to know what I need to multiply to this side to make it, what I need to multiply to this side and to this side to make them both equal. Rather than trying to look at it and trying to figure out the lowest common multiple for both of these, I can also just say what are they both missing in order to become similar. So this side is missing y squared. And this side is missing 3x. So let's go back. Let's rewrite the equation. 2xy cubed plus 5 6x squared y. And then this 3x, let's multiply it over here. And this y squared, let's multiply it over here. I'm going to do this times 3x over 3x and y squared times y squared over y squared. And then what you'll see is that once I do this, you're going to get the same denominator. So we're going to do top part and get 9x over 2 times 3, 6, x times x squared, y cubed, plus 5y squared over 6 times, okay, well, no numbers, no x's, so we're just going to combine the y. So we're going to bring down the 6x squared, y times y squared gives us y cubed. And look, they're the same. Now we can add these. So now we can connect the bridge. So we can rewrite this as 9x plus 5y squared is all over 6x squared y cubed. So let's move this guy. This is your answer. And I'm just going to highlight again. The only way to add these two is to have the same denominator. So we have to change this guy to 6x squared y cubed by adding or multiplying 3x. And to this guy, we have to add y squared. This may be kind of complicated, so let's try this again. Okay, 2xy cubed and 6x squared y. We need to find some value that is as close to these, but makes them the same. So let's see this. Let's look at the bigger one and see what we need to multiply to this side to make it the bigger one. Okay. So for the 2 and the 6, 6 is the bigger one, right? So what do we need to multiply to this side to make it 6? 3. So put 3. Again, x squared. This is the bigger side. So what do we need to multiply to this side to make it this? X. And then for the y, this is the bigger side. So what do we need to multiply to this side to make it y cubed? Y squared. Okay, so take this and multiply it to this side. Take this and multiply it to this side. But not just the bottom, both the top and the bottom. So let's rewrite it. 3 over 2xy cubed times 3x over 3x plus 5 over 6x squared y times y squared over y squared. Okay, and then let's rewrite this. 3 times 3, that's going to give us 9x over okay, so the other thing that we can do, since the bottoms are both going to be the same, once we multiply this together, we only have to do it once. So whatever's on the bottom here, it's going to be the same bottom here. But let's look at it here. If you were to combine these two together, what would it be? 2 times 3, 6, x times x squared, y cubed. So that is our denominator. So let's just bring that down here. 6x squared y cubed plus 5y squared over, same thing, right? That's our goal. So 6x squared y cubed. That's our answer. Awesome. That is probably the worked out version. Okay, yeah, I'm showing here what happens if you try and add like way too much to it. Let's not look at this one. Okay, what other examples do we have? Subtracting. Okay, let's do this one. Okay, so we want to subtract this and this. But again, look, the bottom is not the same. So how do we figure out how to make them both the same? Well, that's x squared, and it's just x. So we definitely need to multiply this guy by something because it's a smaller one. But what? That's not really clear. So to make that more clear, let's break this part into two pieces. So it's going to be something, something times something, something. Okay, so x squared minus 3x minus 4. The 4 is going to be what we need to multiply together. So two numbers, when they multiply, gives us negative 4. But then those same two numbers, when we add them, gives us negative 3. And since we have a negative number, when we multiply them, that means one of them has to be negative. And then since when we add them, it gets negative 3, that means the negative number is going to be the bigger one. So what are the factors of 4? 4 is like 1 times 4, 2 times 2. Yeah, so these guys, they have a difference of 3, right? So that means if you were to have 1 times 4, you would have 4. Cool. But what about when you add them? Which is it going to be? Which is going to be the negative one? It's going to be the larger one, 4. So it's going to be negative 4 times 1. And it's also negative 4 plus 1 gives us negative 3. So cool. That's our factor. Put that in here. X minus 4, x plus 1. All right. I'm going to delete this for now. I'll give you a couple of seconds just to look at it. Okay. So now that we know that this is basically the same as x minus 4 times x plus 1, we know that this guy just needs to be multiplied by that, right? Because it's already x minus 4. We already have that. This guy, this side is just missing x plus 1. So let's multiply x over x minus 4 by x plus 1 over x plus 1. We do the top and the bottom by the same thing so that we're multiplying it basically by 1. So we're not really changing it. So we have x plus 1 over x minus 4, x plus 1. And if you were to distribute this, you would get x squared plus x. Okay, cool. So now we can multiply, or you can subtract this side and this side together. So let's do what all this side is now is x squared plus x over x minus 4, x plus 1. So the good thing is we don't have to write that all over again because this is all going to be over the same denominator. So now we can just bring this guy down to here. So minus 8x minus 12. This guy's not negative. Minus 12 is plus. Okay, so now let's just combine all this together. Then we get x squared minus 7x plus 12 all over x minus 4 times x plus 1. All right, we're done, right? Well, technically, but there is one more step that we could do. You could factor this into some form like this. So let's do that, and you'll see soon why. Okay, what two numbers, when you multiply them, do you get 12? Let's figure out the factors for 12. 1, 2, 3, 4. Okay, 12, 6, 4, and 3. All right. Now, to figure out which of these pairs is ours, we're going to look at this one, the middle number. When we add the pair together, it's going to give us negative 7. But when we multiply them, we get positive. So that means that both numbers are either going to be both positive or both negative. And it's only possible to get negative 7 by adding two negative numbers. So whatever pair we get needs to add to 7, but we're just going to make them both negative. So it can be either 3, 4, or 4, 3. It doesn't matter. Let's just choose this guy. Okay, so let's rewrite this guy as a factor. It's going to be some form like this. And then we're going to add in the negative 3 and the negative 4. Cool. All over. Here, let me move this. This might get a little confusing. It's getting too close to that guy. Okay. And then x minus 4, x plus 1. So basically, I just changed this top side to that. And then what we notice is that the top, both of them have, the top and the bottom, both have an x minus 4. So cancels. And what we're left with is x minus 3, x plus 1. Okay, now that is your final answer. We're now done with that problem. Okay. If you want to see more problems, keep going. Let's see. Let's do... No, I'm going to start this one for a new video. This one might be interesting to a lot of people. And it may be hard for you guys to find it just at the end. Let me know what's like the best number of problems to work out before you guys get it. Like, tell me like what's the perfect number. Like having 3 problems is perfect. Having 20 problems is perfect. Or having 1. Okay, well, let's do this one. So, no, this is different. This is not adding or subtracting. Here. Nah, let's stop this free video here. Thank you for your patience. I really appreciate it. If you have any questions, let me know. Questions. Let me know what kind of problems you'd like to see. Let me know where you struggle. I clearly struggle with writing neatly. Let me know the perfect number of problems. And like and subscribe. All right. Have a good day.